So the last couple methods, I guess, that remain is the notorious when method that we keep talking about. So let's do that. Is it recording yet? Okay. Obviously, this one is going to be public because it's developer facing. Let's create class first. Call stubber. Because our when method is going to return that. So like I said, whenever we call thenReturn, this is where we create our argument matchers. If they're empty, meaning that the method itself is not accepting any parameters, then we use the argument matcher that we created at the top. If it's not empty, then we create an actual argument matcher at the current argument. Then if matchers contain the key, they don't contain a key, meaning that we need to create a new array list to add there. If they do contain it, at this point they will. Current method ID, add argument matcher. And we're going to get all the invocations. And we're going to basically eject the very last invocation call because that is a fake one that we had to do when we called when method, within the when method, if that makes sense. So we're going to remove the very last one. And then return values will also receive new argument matcher for return type. And then current args clear. Basically everything that we do here, we're going to do here again. And so now we can create the when method. Cool. So we are done. This is everything we need to create for our API, and inner working of the library side of things. So to show you that this, obviously they don't work, but to show you that the API is identical, let's just go back to our source code here, and then let's just inside mock test class, let's do some tests, I guess. Let's add some class here. Test class 1. String get name. It doesn't matter what it turns because we're going to mock it later. Get name with params, doesn't matter. Float b string c. It's going to return. Doesn't matter what it returns. So we're going to add that here. Actually, I don't remember the test setup here. Okay, it's doing its thing to add that. Cool. Um, let's do then test. Cool. So obviously we haven't created our Mockito annotations, um, so we don't have means of doing this init mocks, right? Because the annotation processor will actually pump that out. So we don't have that. But what we have is test annotation. And then we're gonna mock it. I'll mock. And then we have um, any int eq for eq test string. Then return test val. Why to do that? As you can see, our API is ready. And then here, we're gonna do verify test class online get name, verify test class one, and then we do this EQ, I don't know, for any no EQ for EQ. Yep, so this is our API. API is ready. We just need to create an annotation processor to actually assign something to this and to make everything work. This was, I'm sure, painful to watch so far, but I hope some of it makes sense. Just to quickly go over what we did so far, or what each of these do. This mock, every single one of our mocks that will be initialized by the annotation processor will have implemented this. Test initializer for each test class we have. In this case, mock test as a whole will have a test initializer class, and we're going to store that in a class that will be pumped up by the annotation processor. And then when we call our Mockito init mocks, which obviously doesn't exist, this method will go find a test initializer for mock test and will initialize this thing, meaning that every single one of these mocks will have an assigned value after that. Um, argument capture captures the values. Argument matcher matches our values for each invocation that a method has. Um, argument matches that they do this. This is basically how, this is a trick for every time, since everything happens here in a particular order. If you look at this, the order of which things happen is the first one. Actually, let's look at line 22 first. These methods happen first, and then this will happen, right? And then we basically abuse that because when you call any int, this will happen. Every single one of your parameters will have passed, all these parameters will have passed in. You know, they will all be passed into as an argument here. So at the end, at the end of our when statement, when the then return type gets called, all of those arguments get turned into an argument matcher, and they get stored for a particular method that's ID'd as current method ID. Obviously, we don't have, this is not being set yet. The mocks themselves will set that. But everything else, as you can see, they're in place. So once the annotation processor is there, creating the mocks in a particular way, this will work as is. I think I'm just gonna cut it here. It's already been a way too long video, and probably not as consumable when it's this long. So I'll be cutting it out for now. If you followed through so far, and I hope you have. I know it's kind of complicated, but it'll make more sense once the annotation processor actually starts pumping out code. Thank you for watching so far.